All right, so this part is new. So we're gonna talk about two events happening one after the other, and we will see instances where the first event affects the second one, and sometimes it's not going to affect the second one. So affects doesn't affect. Okay, so independent events. I'm gonna use two different colors here, green and orange maybe. Right? But independent events are events where the first does not affect the second. Okay? In other words, the total possible number of outcomes remains the same. 49. Example, if you draw a card, you record your results, and here's the key word, you replace it. If you replace the card before you draw another one, the total number of cards has remained unchanged. Okay? So if I tell you that you're drawing two cards, one after the other, but you're replacing it, then not a big deal. Nothing is affected. Like the first one does not affect the outcome of the second one. Rolling dice does not affect the outcomes as well. Even on the second roll, even on the third roll, because you're never removing anything, it doesn't affect the other one. Okay? So that's a classic. Rolling dice does not affect. Spinning spinners. Spinners would be definitely not affecting. One wouldn't affect the other one because you're not removing anything. Okay? But here's where things change. Dependent events. I'm going to use a different color for that one. Dependent events is, we would call events dependent when the first affects the total number of outcomes for the second event. Okay, the key word is no replacement. Okay, so you're not replacing items. So when cards, marbles, candies, etc. are not being returned, you're not returning it after being drawn. It affects the total number of outcomes for the second draw. Okay. So one example could be your teacher picks random students to come to the front of the class. The chances of you being picked next increase since the total number of students remaining is decreasing, right? So as I'm calling students forward, every time I do that, if I haven't picked you yet, your chances are actually going up. Okay. So emphasis on not replacing. So here, let's look at some specific examples where we apply this concept. Okay, so a bag of marbles has 3 red, 5 blue, and 2 green. So 10 total, right? Always figure out your total for probability. If a blue marble is chosen and not replaced, what's the probability of drawing a red marble? Okay. So you're not replacing, therefore, dependent events. Okay, that's for sure because of the no replacement. So this happens first, right? And then drawing a red marble is your second event, right? Second event. But you're not replacing. So what happens in this case, and I give you a visual here, we started with 10, but we're taking a blue marble out. So what you want to think of is you take away that blue one, right? Or cross it out like that is removed. So the probability of drawing a red marble next would be what? Well, how many are left? If I remove one, I'm down to 9, okay? And then you want to ask yourself, how many red ones are still there after removing the blue one? How many red ones are still there? All 3 of them, right? So this would be 3 over 9. And I want to show you that you go 10 minus 1, right? This one right here is being removed. That's why you come up with the 9 there. This could be 1 over 3, which is 0.3333. which is 33.33%. Don't worry, on an exam or on a test, if you state it like this, leave it. Unless I ask you to state it in the other formats, don't bother reducing, okay? Don't bother turning it into a decimal. Okay, so what else can we encounter? Similar scenario. This is your first case. You grab a blue marble. You do not replace it. Emphasis on that. State the probability of drawing another blue marble. So you ask yourself, I took a blue one out, right? That is being removed. So how many are left? You're left with 9, correct? How many blue ones are left if the first one was a blue one? You can tell that we used to have 5, now we only have 4 blue ones left, okay? So in this case, both numbers were affected from my very beginning, the amount that I had at the beginning. So 5 minus 1 gave me the 4. 10, which is the total, minus 1 gave me the 9, okay? How should I do this? I think what I'm going to do here, I'm going to try to be creative. That not replaced is essentially the 1 that you're taking away. In this case, you're taking away both from the blue, which is the top number, and from the bottom, which is 9. Let's do the same up here. Not replaced, that is the 1 here. Okay, bottom line, guys, bottom line. If we're not replacing, at the very least, I would expect you to understand that our total goes down by 1. Okay, that is for sure. The top number will depend on what has been removed, right? Will this number be affected from what I had at the beginning? Well, that depends on the situation, okay? Let's do another one. If the red marble is chosen and replaced, what is the probability of choosing another red marble? So this is your first, and this is your second event. We haven't done this before. We only talked about the one event. What's the probability of grabbing a red face card? What's the probability of grabbing a diamond, whatever. It was just one thing. Now we're saying something happens followed by something else. This is independent. And I want to be careful here when it says replace, it almost doesn't matter what happened first, guys. You understand that? It doesn't happen. Like, why do you tell me that I chose a red marble? If you're putting it back, it could just be like, what's the probability of choosing a red one? Because it doesn't matter. It's been reset, right? The situation has been reset. So when it's independent, we go back to, it's still 10, right? And we still have all three. Even though we did choose a red one, they're all back. So 3 out of 10 it is. Okay. So that is your answer there. Nothing changed. Okay. So that's basically what I want you to get out of this lesson. Let's go to 50. And let's try this here real quick, okay? So if a green marble is drawn and not returned, what's the probability of drawing another green one, okay? So right away, you want to go with 9 because you're not returning it. You have removed the green one, so as far as I know, that one is no longer to be considered. So you're down to just one. So just one green one. So this will be 1 over 9. Again, a blue one is chosen first, not replaced. What's the probability of a red marble? Oh, sorry. I jumped the gun on this one, sorry. Blue marble first, then a green marble. They're both not replaced. What's the probability of getting a red one on the third draw? How many have we already removed before the third one? 2, right? So we're down to 8. Now, we want a red probability of a red one. Have the first 2 events affected the number of red marbles? No. So we still have all 3. Okay. But I want you to go to the bag and let's take out a blue one and let's take out a green one. Okay. So just to understand, there's 8 left. 8 left. And that's what came up here. Okay, so this is rare, to be honest, where it's like 3 events, but I want you to think of that just in case. Okay? Let's do the bottom 2. Can I ask you to fill that out right now yourselves? Like, answer both of them, read carefully. It's not always dependent. Answer those 2 before I get you to do some work on your own. So the first one is a red. So red first, then a green one. They're not replaced. What's the probability of a red one on the third draw? I'm down to 8. Okay, so this is your first event, second event. That happened before this, so we started with 10, we're down to 8. If I want a red one, I recognize a red one has already been removed. So I'm down to 2. I started with 3, but I removed a red one, and I removed a green one. So I'm down to 2 out of 8. Okay, so both numbers have been affected in this case. What about the last one? A green one has been chosen, another green one, but they have been returned. Nothing changes, guys. It's almost like, why did you tell me about the first 2? I don't care. I still have 10. I want that green one, so there's 2, so it'll be 2 out of 10. Nothing removed, okay? Which is an example of independent events. These 3 that are being talked about, they're independent. They don't affect each other, okay? I would add that to my study sheet. Independent, first event does not affect the second. Dependent, first event does affect my second, okay? Okay, so I'm going to ask you to, that's all that I had to say for now. 51 to 53, if deck of cards isn't your thing today, skip the deck of cards questions. Do the marbles, do everything else. Just make sure you wrap your head around this one. So basically, you know what? 53 and on would probably do that, okay? So I'm going to change my pages 51 to 55. That way you get to skip cards. If you don't want to do cards, then that's your choice there.